Okay, hi, this is a question from WJEC GCSE Mathematics Intermediate Unit 1 paper, non-calculator. Okay, let's have a look at this. Express 700 as a product of its prime factors in index form. Now, basically, if you've practiced lots of these, this should be fairly straightforward. So I'm just going to go through the motions and show you what that means. So remember, a factor is a number that divides into another number, whole numbers, I should have said. It's a whole number that divides into another whole number without leaving a remainder. So a prime factor is a prime number that divides into another number without leaving a remainder. So what we need to do is to take 700, and there's two ways you can do this that I know of. I use a ladder, that's my favourite way, but there is a tree which I'll do on the other side as well. We're going to divide this 700 by prime numbers, prime factors. So if it divides into it, then I will continue to do so. Now, the first thing you need to remember, obviously, is some prime numbers. If you don't know what prime numbers are, then you've got no chance of doing this question. So it's a good idea to know them at least up to 20. That should usually get you through this type of question. But if you know a few more, then even handier if they crop up. But just remember what a prime number is. It's a number that only has two factors, number 1 and the number itself. It doesn't have any other factors at all. So prime numbers only have two factors, number 1 and themselves. Okay, so you can always check if you're not sure if a number is a prime number. So prime numbers up to 20. We've got 2, 3, 5, 7, 11, 13, 17 and 19. That should get me through this question. So I'm going to start off with number 2 and ask myself, does 2 divide into 700? Well, of course it does, because this is an even number. Okay, I'm going to zoom in a bit more. That's an even number. So 2 can always be divided into an even number. So how many 2's in 700? 350. Just halving it, aren't we? Can I still divide by 2? Yeah, so I carry on. Half of 150, 350, 175. Double check, I'm going to double that. 200, 350. Now 2 doesn't divide into 175, so I'm done with 2. Now I'm going to try 3. Does 3 go into that? Well, there's a check to see if 3 goes into a number, is add up the digits. And if 3 goes into the total, then 3 will divide into the number. Well, 1 plus 7 is 8, plus 5 is 13. 3 doesn't go into 13, so 3 won't divide into that. Now I know you could have jumped straight to 5, because it ends in a 5, but I'm just being logical and going through them one at a time. So 5 definitely goes into 175. How many times? Well, how many 5's in 17? It's 3, remainder 2. I'm doing a bit of short division here. I knew it didn't go into 1, so I just looked at 17. 3 5's are 15, remainder 2. How many 5's in 25? 5. Does 5 go into 35? Yes, so I keep going. Then I get 7. I know 5 didn't go into 7. Well, the only thing that does go into 7 is 7, because that's prime. And the answer is 1. Now, when you get to this point, you stop. You know you finished. Okay? Now, if we're going to do the tree way, then you take 700 and you split it into a prime factor, if it goes into it, and the other number that it multiplies by to equal 700. So 2 goes into 700 350 times. And you keep using 2 in the same way. Okay, and then I realised 2 doesn't go into that. 5 does though. 35 times. Notice I'm circling the primes. I'm not circling the numbers that are not prime. So I only circle the prime numbers, the prime factors. And then this 5 goes into that 7 times. That's prime. So that's the method using a tree. Okay, so I prefer the ladder because I think it's just a bit neater. Now what you're meant to do, because you have to express them as a product in index form. Now product, remember, means multiply in maths. So we need to write down all these prime factors as a product. So basically 700 equals 2 times 2 times 5 times 5 times 7. And it does, if you actually multiply that out, it equals 700. 2 2s are 4, times 5 is 20, times 5 is 100, times 7, 700. So that's all we've done. Every number, every whole number can be expressed as a product of prime factors. Okay, so that's what we've done. Now we haven't done the last bit, which is index form. And that means using indices, using powers. So we combine common factors that you can see in there. So we've got 2 2s. So instead of 2 times 2, I can write 2 squared. Times, I got 2 5s. So instead of 5 times 5, I can write 5 squared. And I've got 1 7. And there we have my final answer. That's the product of prime factors in index form. Okay? Now there's one little question tagged on the end here. And this mark is quite often lost by pupils, and it's very straightforward. It's only 1 mark. They have asked this question in different ways sometimes, but it's all based around the fact I'm about to tell you. So the number, now let's have a look at this. This looks like 33,554,432 is equal to 2 to the power 25. Explain how this tells you that 33,554,432 is not a square number. Well, it's all about the power, all about the index. 2 to the 25 is not a square number because the power or index is not an even number. And that's that. So basically, if the power is even, if that was 2 to the 24, then that would be a square number. Okay? So that's all you have to say with that, is the power is not even, therefore it's not a square number. In fact, 700 is not square because all the powers in the answer above were not even. We had an even power on the 2, we had an even power on the 5, but we've got an odd power on the 7. There's an invisible 1 there, isn't there? If that was 7 squared as well, then all the powers are even, then that would represent a square number. Okay? If you think about it, if I did multiply by another 7 to get 7 squared, that would times this by another 7, giving me 4,900. Now 4,900 is a square number because it's 70 times 70. Okay? Hope that helps. Thank you very much.